In section 6.4, we're going to talk about sampling distribution and estimators. So the sampling distribution of a statistic is the distribution of all values of the statistic when all possible samples of the same size n are taken from the same population. So what we're saying here is if we're trying to find the average of something, we're going to pick some sample size, say 5. And you would take all possible groups of size 5 and find all of their averages, and that would be your distribution of those values. The reason that we take sampling distributions is because samples are easier to get than a census. And for certain statistics, the values target that of the entire population. So what we mean by that is, for some of the statistics, some of these values that we look at, taking these small samples over and over again will give you a good sense of what it is for the whole population. That's what it means to target. Where they are not useful, we say they don't target. So statistics that target the population parameters, or another way of saying that is where the sampling distribution would be useful, are the mean, the variance, and the proportion. We also call these unbiased estimators. Statistics that do not target the population parameters, the ones that we would say are biased, are the median, the range, and the standard deviation. So with any sampling distribution, we sample with replacement so that we have independent samples. So you would be putting it back each time. So here we're going to go through an example. So it says, we will begin by conducting a sampling distribution of the mean. Here are the heights of 4 blue spruce trees to the nearest foot: 13, 16, 12, and 11. Assume that the samples of size 2 are randomly selected with replacement from the population. So we're going to make every sample of size 2 from 13, 16, 12, and 11, and we can repeat the values. So for example, we could have 13 and then pick 13 again. Or we could have 13, 16, 13, 12, or 13, 11. Now I'm going to pause this while I fill in the other 12, so I recommend that you also pause the video, fill in the rest in your notes, and then check it when I press play again. Okay, so I've listed all of the 16 samples. Now before we go any further, we want to know what we're actually trying to see if this matches. So the average of these 4 heights, if we take 13 plus 16 plus 12 plus 11 and divide by 4, we get 13. So the average of all 4 of them is 13. Now, we're going to average each of these samples. So for each of the samples, we're going to add the 2 numbers and divide by 2. So 13 plus 13 divided by 2 would be 26 over 13, so we'd get 13. So I'm going to find the mean for all of these samples, which I would encourage you to do as well. Again, I'm going to pause it, fill in these values, and then continue on. Okay, so I've gone ahead and filled in all of these means. Now we're going to identify the probability of each sample and describe the sampling distribution of the sample means. So this X bar, this is going to be all of the different averages that we found in these 2 columns. So the lowest one we found was 11. We also had 11.5. We had 12, 12.5, 13, 13.5, 14, 14.5, and 16. Now, the probability of choosing any of these will be how many times that occurred over the total number, which is 16. There were 16 different samples. So 11, how many times did 11 happen? Just once. So we'll have 1 over 16. Then we want to know how many times did 11.5 happen? So 1, 2. So that'll be 2 over 16. For 12, if we count them, we have 1, 2, 3. So 3 out of 16. For 12.5, we have 1, 2. For 13, we have 1. For 13.5, 1, 2. For 14, 1, 2. So 14.5, again, 2. And for 16, there was just 1. Okay, so it says put in your calculator to find the mean of the sampling distributions. So to do this, we're going to go to Stat and Edit. We're going to put the X bars, the left-hand column in L1, and the right-hand column in L2. So I'm going to go ahead and pause to put these in. Okay, so I've gone ahead and put them in, and when you put in a fraction in L2, you can just put, for example, for the first one, 1 divided by 16, and it will make the decimal for you. So to find the mean of this sampling distribution, we're going to quit out of here. We're going to go Stat, over to Calc, and choose one variable, Stats. In L, for a list, we're going to have L1. For frequency list, we're going to do L2. If it doesn't bring up this menu, you're just going to put one variable, Stats, L1, comma, L2. Okay, and we see that the mean, it gives us 13.0, so 13. So is the mean of the sampling distribution equal to the mean of the population? Yes, this value matched what we had above. We're going to do this process one more time, but with proportions. So this says, here are the numbers of students in 4 different sections of statistics. So how many students are in each class? 22, 15, 28, and 30. So it says, assume that samples of size 2 are randomly selected with replacement from this population of our 4 values. We will construct the probability distribution for the sampling distribution of the proportion of sections that have more than 25 students. So we know of the whole population, there are 2 of them that have more than 25, so 2 out of 4, or 1/2. So the first thing we're going to do, just like we did before, we're going to list the 16 different possible samples. So we'll start with 22, so 22, 22, 22, 15, 22, 28, or 22, 30. Again, I'm going to pause this and fill the rest in. Okay, so those are all filled in there. Now in the p-hat, we're going to come up with, out of those 2, how many out of 2 are... So I filled in the samples, and I also went ahead and filled in the proportions. So that's how many out of the 2 are bigger than 25. So where both of them are less than 25, that would be 0 out of 2, so I put a 0 there. When one of them is bigger than 5, that would be 1 out of 2, so there's a 0.5 next to those. And when they're both bigger than 2, that would be 2 out of 2, which is 1, so there's a 1 next to those. So we're now going to do just like we did earlier and create the sampling distribution. So the different proportions we had here are 0, 0.5, or 1. And we're going to say how many times that happened out of 16. So for 0, we had 4 out of 16. For 0.5, we had 8 out of 16. And for 1, we had 4 out of 16. So on our calculator, we want to find the average of this distribution. So we're going to put the p-hats in L1 and the probability of those in L2. So here we'll have our 0, 0.5, and 1. And over here we'll have 4 out of 16, 8 out of 16, and 4 out of 16. And just like we did before, we're going to go stat over to calc, one variable stats, L1 and L2. And we want to look at the average here, which is 0.5. Which notice, like we said before, proportions is unbiased, so that matches the 1/2 we had up here. So they did equal each other. If we had done this with standard deviations or ranges, we would find out that they don't match.